Alright. This is the AP Precalculus Unit 2 review, and disclaimer: AP is a trademark registered by the College Board, and it's not affiliated and does not endorse this research nor the 5 team. Alright, credits to Brian Passwire for all the questions in the slideshow. And 5 Hive, I think you all know about it. It's a volunteer organization. And I posted like the feedback form and where you find the recording eventually. So we'll get straight into it. The first topic is arithmetic and geometric sequences. So this is what the CED says, and there's a lot of information. It says a sequence is a non-continuous curve and its discrete values. It shows an arithmetic equation and a geometric equation. So then we'll go straight into the equations. Arithmetic formulas are a1 plus n1 minus d, and if you have any term, you can say ak equals am plus k minus md. And one property that's important is that they have a common difference or a constant rate of change, or similar to linear functions. And like it says, linear functions, and they're not continuous. And then you have, and they increase equally with each step, or the slope stays the same. Is a AK point slope form as well? Yeah, it's similar to point slope. Alright, so now, would you guys like to try this question first, or me explain one then try? Okay, I'll give you like a minute. Matrix the vectors are not in the AP test. Yeah, question 3. This question 3 uses formula number 1. It actually doesn't matter which formula. You can use any formula, so I'm not gonna say which formula. Yeah, you don't have A1. You can find A1, but yeah. Can you please spoiler your answers? And the answer is negative 19, as a lot of people put. So as Guac put, it's yeah, negative 3, and because 3 terms in, and then you would plus 7. Where did you get the 17 from? So the way I would do this is you would say this is the third term and you have an 8, and you have to go 12 terms out, which means you're going down. For every step you're going 1 minus subtracting 3. So that means our fourth term would be 5, and our fifth term would be 2. And that means how many steps is there? There would be 9 steps, which means you're minusing 27, which would get you negative 19. Is the way I would solve this, but you could also use the formula if you prefer the formulaic way. So now try number 4. What's the last? I think it's semi-log plus is the last topic. 2.15. Memorize. You don't have to memorize it, but if it asks you to write an equation, it would be useful. Alright, try number 4. This is with 2 terms now. How do you graph tangent function? You do need to know the properties of the tangent function and how to graph it. How long is this lecture gonna be? Hopefully until 7 to 7:30, but depending on how long each question takes and stuff like that, it may take longer. In 3 hours. We'll say in hopefully 3:30 out. 3 hours 30 minutes, and hopefully it'll be less, but we'll see. So give me like a minute for this. Well, you do. We already did. We have 2 Unit 2 reviews, and we have 2 Unit 3 reviews, and they're on the lecture like form, which is above. Like if you scroll up, I posted like all 3 of them. Yep, the answer is 18. So, anyone have any questions on it, or can we just move on? Can you explain? Sure. So, we have to first find D, and I'm gonna do the same way I did before. So we have 2, 3, 4, 5, and the 6th term. So our second term is 7, and our sixth term is 9. So how many? And then there's 4 terms in between. So that means this 4D is equal to 4D plus 7 is equal to 9. And 4D is equal to 2. And D is equal to 1/2. And then you would use the formula. A of n is equal to, and you have to subtract. It says start with A1 for this formula. So we'll go to A1. And usually they say to start with A0, so we'll start with A0, which would be 6 in our situation, plus 1/2 n. And then you would plug in 24, which would be 12 plus 6, which would be 18 for A of 24. Why are we putting... it's not 7 over 2, that's just... This is the second term. This is the second term. 7 over 2. It's the second term, and I'm just labeling it as 2 for now. Alright, so now just determine if the sequence is arithmetic. I'll give like 30 seconds for all 4. And then if yes, identify the common difference. Can you not hear me anymore? Or can't hear you? You can hear me. Okay, good. Okay. So can you hear me? Okay. Does this help? Maybe if I bring it closer. Bring the mic closer. So I'll go over the answers. The first one is no because it has a quadratic, so that means it's not linear. The second one has a difference of -2 because it's a linear function. This one is yes because it's adding 5, so D is equal to +5. And this one is switching between positive and negative, so it's not. Now we're going to move on to geometric sequences. Geometric sequences have 2 formulas. They have g of n is equal to g of 0 r to the power of n, and g of n is equal to the whatever term in r n minus k. And this is called the first term, and this is called a common ratio. My voice keep cutting off. Is this better? Wait, am I cutting out still, or you're good? Okay, I'm good. So perfect. It's not you. Okay. Okay, I'm not talking, so I don't think you can hear me if I'm not talking. Okay. Property of successive terms, they have a common ratio or a constant proportional change. And geometric sequences behave like exponential functions except they're not continuous. Increasing geometric increase by a larger amount each step. And percent increase always stays the same. Okay, yeah, so try leaving. Okay, I wasn't talking, so let me test. Let me just change the Discord setting. Let me see if that helps maybe. Hello? Okay. Discord says it working perfectly, so I can try joining and leaving if that helps. You can hear fine. Okay. So okay. We'll continue, and if it becomes an issue, then works for like 2 seconds and then cuts off again. Okay, I can try leaving and joining in 1 sec. Try leaving and joining 1 sec. Oh wait, it'll end by itself. Okay. I'm back. Does that fix anything? Did that fix stuff for anybody? I'm fine. Okay. 1 sec. So okay, my Discord crashed, that's fun, but yeah, try restarting the app maybe. So we'll continue. Can you guys see the screen? Because I did some resets. So yes, you can. Okay, and we'll continue. So first, g of n is the first term is 8, and it goes down to 4 at the second term, which means we have a 1/2 ratio for every n. And that's pretty much it. The answer to this, oh, skip 7. 7 would be 12 times 2 to the n minus 1, I'm pretty sure. Yeah, it would be 12 to the n minus 1. So g of 4 would just be plugging it in, so 2 to the 8. 2 to the third times 12. Okay, do these two make sense? Okay. So we'll move on to the next one. What is the answer to these questions? For both, we'll do all, okay, we'll do the first two together. I'll give you like 2 minutes for both of them together. For the other one, why wasn't it 4? Because you're looking for g of 1. Means for example 7 or 8. 8. Alright, so first the expression is 8 minus 1/2. Does that make sense? Alright, so as we talked about up here, the first g of 0 is Rn to the power of n. So that means the first term at 0 is 8, because there's a point here. At the second, it goes to a 4, which means we're multiplying by 1/2. And then you have to also find g of 10, which is just 1/2 to the power of 10. Or 2 to the power of -10 times 8. 2 to the third times 2 to the -10, which would be 1 to the power of 2 over 5. For g of 10. And simplify that. Is it n minus 1? I used 8, so you don't have to do n minus 1. If I use 4 as my first value, then it would be 1/2 n minus 1. You can use, so if you use 4 as your first value, then this is your thing. If you use 8, then this is your thing. Yeah, half-life is just pretty much this, just starting with 1/2 is your ratio, 100%. So we'll move on to 2 and 5 now, if there's no other questions. It is being recorded, and I was not talking at the time, so. I answered both of them, by the way. Answer 2 and 5. And we'll go over them in about a minute. Geometric formula is g of n is equal to g of 0 times the ratio n. The first one is D, and the second one is B. Any questions about these two? Can you explain this one, or question 2 or question 5? We'll use the number. Question 2, okay. So this starts, so we have a term at 1, right? So that's one value would be 9. And then we're going down by, for every 1, we're going down by 3. Which means our ratio, so if we make it equal to 6, we'd have to be multiplying by, okay, if our R value is here, we divide by 9, and R is equal to 2 over 3. So it can't be C. Then it can't be this one, because we started at 1. So there needs to be an n minus 1 for this one to be true. So it can't be this one. For this one, same issue. Now that we're at the second term, it has to be n minus 2, which leaves this one because it's 4 and n minus 3. How do you get n minus 3? Because if we use this formula, right? G of n, we're starting at g of 3 right now. So we have to account for that by subtracting 3 to make this be equivalent. So does everyone understand number 5? It's an arithmetic sequence. I forgot to do it. So this would be a of 4 is equal to 30, and a of 8. Number 5 is B. And a of 8 is equal to 54, and then solve using whichever way you prefer. And now we'll move on to should be another 2 hours, hopefully. But we'll go as long as we need to finish everything. Great, thank you. So number 7. I'll give you like 20 to 30 seconds. This one. And also my world, more colleges do accept it now, and it could be also useful for non-STEM majors, and it could be useful for preparing you for AB, or maybe some schools allow you to skip to BC with AP Precalc. So yeah. Okay, and number 7 is A. And it's also a good way to prepare for your first math AP as well, because you get to see how an AP test looks like for your first math AP, instead of just going straight into AB. So this is A, and it's because of the same way we do linear functions like tables. This is +1, +1, +1, +1. So there's a constant rate of change. And then we're subtracting 6 at the same pace here, which means it's arithmetic. You put this on both sides of your answer. So now we'll move on to number 9. It's an arithmetic sequence where B and C are constants. What is the answer? What is the value of B and C? Okay, 30 more. Remember to spoiler your answers. Can you make polls? If someone could make the poll for me, but I don't have the ability to make polls while being in the way I have the recording set up right now. Thanks. Cool Savage. I'm okay, I'll go over it now. Number 9 is C. Number 9 is C. This is recorded and will be posted hopefully by tonight if everything goes well with uploading. Can you explain? Sure. So it's a arithmetic sequence. We have 2 terms that are given. We have a few terms that are given completely. So we have at the 5th term and the 7th term, we have 32 and 26, which means so 32 plus 2, like D for this case, equals 26, minus 32 on both sides to solve for D, and that would be -6 is equal to 2D, and D is equal to -3. So that's our D ratio. So now we have to go find B first. Or actually, we'll find C first, because that's a lot closer. So then we just have to subtract 3, which means C is equal to 23. Now that we're going backwards, we have to add 3. Specifically 4 times. So 32 plus 12 is equal to 44 plus 23, which is equal to 67. Any questions? No? Now we're going to move on to 2.2, which is change in linear and exponential functions, which is pretty much the same idea, but now it's in context and paragraph. You could use the arithmetic equation, or you could do, I think this way is easier because there's no formulas. You just have to think about how many terms, and then you have to like make an equation to find other terms. But try number 11 and 12. Now 12 is a calculator question. You could also plug it in if you figured out the formula from these two terms. Yeah. So this is sort of a continuation of arithmetic geometric, but it's also not completely arithmetic geometric. Okay, I'll give it like another 2 minutes for these to change in linear and exponential functions. I'm not. To spoil it, you have to do this on both sides of your answer. So like, can't really. Yeah. So it looks like a lot of people have done 11, and that is B. You have to put another bar. So it's 2 on each side. It's 2 on each side. And number 12 is a calculator question, so you're gonna need a calculator or a Desmos or TI or something. Or you could just try guessing the answer, like estimating it. Okay, I'll give like another 15 seconds because this is just plug in your calculator question. Okay, and the answer for this one is C, which is right according to your college board skills. So the way you would do this one is, it says it's geometric, and that means it would be g of 6 is equal to 750, g of 10 is equal to 3200, and then, so you can make equation g of n is equal to 750 times, actually, hold up. Then you could say 3200 is equal to 750 times r to the power of 4, and then solve for r. You could use a regression, but this is similar to a non-calc question. If you could do this without non-calc if it was smaller numbers. The equation for geometric and arithmetic are these. This is geometric, and this is arithmetic. I'm getting number 11, which was 11. This one. So it says at year 3, so that means a of 3 is equal to 50. You can use either one. You can you can know, it's better to know both, but you can also the way I was doing with just like you have a term and you have to find out how many you have to go. You have a of 3 equals 52 and a of 6 is equal to 61, which means 61 is equal to 52 plus a difference of 3, solve for d, and then that's your slope. And then you would go back 3 terms to get this y-intercept. And that's it. Hope that answered your question for whoever had that question. We're gonna move on. So now we're moving on to exponentials. This is similar to our geometric sequences that we just went over for the last 30 minutes. So yeah, you're using the arithmetic formula because it says it's an arithmetic sequence. And this one said a geometric sequence. And that's how you decide which formula to use. Now we're going to move on to exponentials, which are similar to our geometrics, but now they're continuous. A represents the initial amount, and B represents our value that we're pretty much multiplying by. Yeah, or our ratio, which is a better word, a ratio. Or the common ratio. Yeah, there's multiple words for it. And to answer, is Desmos available on the test? Yes, I will be going over Desmos tomorrow at around 6:30. So exponential growth is when b is greater than 1, and exponential decay is when b is between 0 and 1. Increasing exponential functions are always increasing or always decreasing. They never switch from another, so they have no relative, local, or extreme amount. Concave up or concave down. Exponential functions are always one or the other. They have no points of inflection. End behavior, as the values increase or decrease without bound, the output values will increase or decrease without bound, or they will approach 0. And the end behavior limits are as it's positive and negative, they approach infinity. It's positive and negative, they approach negative infinity, or they approach our horizontal asymptote. So now, our first question. Select the values of the function f are given in the table below. Determine if f could be linear, quadratic, exponential, and none of these. And I'll let you guys try this for like a minute. And for exponential functions, we're doing example 3 first. We're doing example 3 first. It's linear, quadratic, exponential, and none of these. Remember so for this first one, it would be, so the answer would be, you have to find see if you can see that it's linear, at least one side, it's proportional. It increases, and the rate of change increases at the same pace. This goes by 2, this goes by 4, this goes by 8, and this goes by, I think, 16. And this goes up by 2, this goes up by 4, this goes up by 8. And that means it will be exponential because, as you can see, the ratio is increasing by multiples of... Oh wait, no, it would be none, because it would be none, because I think it would be none because, okay, it's none. Because this is plus 2, it would be, it's not, to be exponential, it has to be multiplying by 4 on its first consecutive term. So It's not second difference, because if you look at the second difference, I think, because I don't have the answers to these. So, the Cool Savage, could you check if this is quadratic or exponential or none? I don't think it's quadratic, because this would be plus 2, plus 4, plus 8, plus 16. This would be plus 2, plus 4, plus 8. Not exponential. Alright, hold up. Let me just check in Desmos. Let's just check in Desmos once. Let's check if it looks like a... Check if it looks like... Not exponential. Okay, it's not exponential in Desmos. Okay. Then it's none. If it's not exponential, it's one of these. So it's not. Yeah, you could do a regression. That's why I was checking the regression for this. It's none because to be exponential, it would look something like this. It would be 1, 2, 3, and it would be like 2, 4, 8, because it goes multiplying by 2 on the first term only. Subtract 1 here. Okay, I can test that. 2, 4, 8, 16, 32. So yeah, you could do that. That's another way of doing it. Because there could be an n minus 1, so I guess it would be exponential if you did that. How can we prove that it isn't exponential? If you find it has an nth difference of 1 or nth difference of 2, like Savage went over yesterday with like linear and... Okay, hold up. We'll restart, because looks like everyone is confused, including me, because it's me question. There is no answer key. There is no answer key for this, because these are notes. There's no answer key for these. So we have this. This eliminates it being log. This eliminates log. This one, if you, okay, and I forgot who said it, but yeah, if you subtract 1, it is exponential. And the reason that works is because your formula could be a of b x minus 1. Yeah, a of b x minus 1. So like this, a of b x minus 1, where it's a y-intercept. Which means now if you do that y-intercept transition, now that would multiply by 2 perfectly. Which means it would be exponential. Yeah, Guac, it kind of got confusing. Alright, I'll find an answer to this and I'll come back and I'll send this in the AP Precalc channel when I find it. I'll find the answer somewhere on Google and find the exact answer to this question and come back. We'll move on for now though. A and B is your A is your initial value, B is your ratio. Okay. So we'll move on. I'll find an answer while you guys work on these 2 questions. So do 13 and 16, and I will find an answer somewhere, real quick. Cause, well, you make notes on an answer key. Cause last time I posted the answer key, it did not work out so well. Cause people said it was unorganized, so I didn't put the answer key this time. I have the multiple choice answers because they're from like a packet I posted in the Precalc channel, but I found the answer. It is exponential. For this one, it is exponential. Okay, and okay. And don't do that. Alright. So the explanation that I found has, and so pretty much the way the explanation I found on Google says it's 2 of 1 plus 1, 2 of 2 plus 1, 2 of 3 plus 1. And that's how they did it. Because it's like a, alright, so if you see this, right, this is an exponential function, right? You can have a shift upwards, like a vertical shift upwards. Or, yeah, 3, and this could have a vertical shift downwards by -1. Which means that these ratios, this y values change depending on your shift, your vertical shift, or yeah. Yeah, the y difference is proportional if you subtract 1. The ratio with even without the -1 is, it's not proportional with we're talking about example 3, the argument question. That makes it exponential then. Yeah. Alright, so the answers for 13 and 16 were 13 was D and 16 was A. Any questions on these two? Then you get this. It gets better. Can you show? Okay. So for this one, if we see this, it says if B is between, it's decaying, and it's positive. So then yeah, it helps to draw a diagram. So it looks something like this, which means as it's going to infinity, negative infinity, it's going up to positive infinity, and it's approaching infinity, it goes to 0. For this one, same. So now it says 5 of x. The a value for this does not matter because it's 4, which means that means our starting value is 4, pretty much. Like example 3 on the test. 3 isn't crazy. This would not be an FRQ. This would be definitely an MCQ. This is not a type of FRQ. For this one, you first graph it without the vertical flip. So the 5 of x would go up like this, and then after the flip, it would flip downwards, which means it's going like this. Which means as it's going to negative infinity, it's going to 0, and as infinity, it goes to negative infinity. Do these two make sense to you? Explain 16. 16, once more. Alright. So first, graph it without the vertical shift, without the negative sign, so you get a positive function going upwards. And then add the -3, which means you flipped it across the y-axis. One sec, I'll check that. And that's it. And this would be, because it's going towards negative infinity. Example 3 is kind of a stupid question, I agree. Difference is still 37. Yeah, that is another way of doing it. That's the first way I did it, but then people got confused, and I got the 2 times x. So this is the same idea of it being 2, 4, 8, and 16, which is proportionally getting multiplied. The graph exponential. I didn't check it. I can check it once. Okay, if you graph it in Desmos, it looks something like this, which is a perfect exponential curve. Which is a perfect exponential curve, as you can see. And you can even see the asymptotes going towards 1. Any questions on these 3? If not, we'll move on. Now 21 to 28. 21 to 3 questions. What question do you have, Rumbling? Oh, okay, you can move on. Answer the questions. We'll come back to that. I'll find a better way to explain that in tomorrow's lecture and during the Q&A. I'll definitely find a better answer to that question on the tables, for especially a shift. So answer 21 through 28. So then, I'm going to spoil Rhapsody. Do one. So the first one is D. The 27 is also D. And 28 is B. Any questions about any of these? No? Which one do you have? Could you go with 28? Sure. So this, so we know it's a decay function, so it's going to be looking like this. And then we flip it over the y-axis. So it's going to look something like this. So this is the old, so now we look at this, and it's below the y-axis. Which means you flip it because it's -6, which means it's a flip over the y-axis. I mean x-axis. Flip over the x-axis. Flip over the x-axis. And that means now you can see that it's always increase. A negative in the front is always flipping over the x-axis. Yep. That's the same thing as like a quadratic. So if you have like x squared, negative x squared is now like this. It'll be negative. Shouldn't be negative b because I don't think that exists. A negative b. I don't think a negative b value exists. Yeah, b is supposed to always be greater than 0. So yeah. And you can see that it's always concave down. But because as the Cool Savage explained yesterday, the secant lines slopes are decreasing, so the rate of change is decreasing. Any other questions? So then just apply the normal path with a negative and then apply the C. Yeah. First, graph it normally and then flip it, because that's the easiest way. Now do 33. I can't put both of them. So do 33. I'll give you like 30-ish seconds. It's just about knowing if it approaches the asymptote or not. Sort of. Yeah, it's just to see which way where is it going to negative infinity, positive infinity, and etc. Okay, and 33 is. I'll give it 10 more seconds because there's 3 more people still typing. You have to put the straight bars. Straight bars. So 33 would be C. No, 2 on each side. 2 on each side. C and D are too similar. Could you explain? Okay, the difference is the outputs and the inputs. If the inputs are proportionally over equal value lengths, it's log. If the outputs are proportional over equal, it's exponential. And that's the difference. How do you... I'll show the 35 in one sec. How do you know if it's log or exponential? Can you explain with the over equal? I'm not confused this time. Yeah, sure. There's still more. There's a lot more of that. Semi-log is confusing. We will get to semi-log at near the end because that's the last topic in Unit 2. So maybe a while. The input is exponential, then it's log. Yeah. 35. With a negative a. No, because the asymptotes are different. Because yeah, that's the difference. Log has an x. Yeah, look wise, it could, but you'd have more details than just. It would show the asymptote, usually, or the y asymptote, or something like that. This lecture will be on the 5 Hive YouTube by most likely tomorrow if it gets uploaded quickly. Must be a quadratic. Okay, 35 is... This is the AP Precalc wording. I don't think you have a name, so I can't really say it. Just to blink. That's all AP Precalc wording. This average rate of change is over consecutive equal length. Can we do polls? If someone makes the polls, I can't make the polls well the way I have this recording set up. You click the addition button and you click create a poll. Okay, and the answer to this question is C. Because the output values are proportional. Of course. Are you just still... Have you just been here the entire time, or did you just come back? Alright, now we're gonna review some important exponential rules. By proportional, that means just multiplying. It's like multiplying by 2 if you have... Yeah. What would make it quadratic if it was nth differences? So if you had like 1, 2, 3, and a 4, and it was 1, 4, 9, and 16, it would be plus 3, plus 5, plus 7, and the second difference is plus 2, and they match, so that means it's quadratic. Okay, in logs, the input values, yeah. Okay, so now we're gonna review some important exponent rules. This is where the solving starts for exponentials. So the product rule is if you multiply 2, that you can add them together. The product rule is if you have the power of something, then multiply them together. And the negative exponent rule is if a negative, you put in the denominator. I hope everyone knows that by this point, these 3 rules. Okay, important idea. Every horizontal translation of an exponential function, where b of x plus h, is equivalent to a vertical dilation of the exponential function a to the b of x, where a to the b of h. This will be... I can't guarantee it because I haven't taken the test, but there could be an MCQ on this. Just the idea of this in the non-calc section. So try 37 and 41. And if someone could create a poll, that'd be appreciated. Nope, it's the straight bars. Straight bars. How do I do straight bars? It's if you have a normal keyboard, it's above the enter key and like below the delete key. Or you could just type /spoiler. You could just type /spoiler and type your thing. That also works. I'll have to do, yeah, okay, and you got it. 37 is B. And any questions on 37? How do you get that? Alright, so 3 times 4 to the x plus 2, and if we take this idea that we've shown up here, it would be 4 to the x times 4 to the 2 to 3, and this would be 16 times 4 to the x times 3, 48 times 4 to the x, combined like terms, or multiply like terms. Can we review 2.1 at the end? Yeah, if there's time, we can review 2.1, or we'll review it tomorrow again, with maybe some trig during Q&A. Try 41 now. $41 is C. Any questions on how to do 41? 41, it's because same idea as before, 4 to the x times, yeah, and then you would split that into 4 to the negative 2. $41 is C. Yeah. And 4 to the x, and no, I did not say B. If I said B, then I think I read it by accident. Okay. But if I said it, my bad. If not, and 4 to the power of negative 2 is 1 over 16. And that's what I'd see. It would be B if it was positive 2. If I said B, it's my bad, but I meant to say C and I circled C. My apologies. So last question, 43. The function of f is a horizontal dilation of y is equal to 3 to the power of x, and f of x is equivalent to square root 3 of x. Which of the following could be an expression? I'll check real quick. Find the points where log x intersects 2x minus 14. I can solve that later when we get to the equations. We will get to equations. I think that's after exponential modeling. Alright, 43 is A. Because the square root is equal to the power of 1/2. And that's pretty much the idea. And the cube root is equal to the power of 1 over 3. And that's it. Any questions on 43? Before we move on to the next topic. Nope. Okay. So now exponential modeling. This is very similar to what we did before, but also different at the same time. So yeah, this is half-life now. So an exponential model can be constructed if you use either the common ratio, the initial value, or two input-output values. The same as geometric sequences. So, or you could use Desmo / the TI-84 to make these. And this is similar to FRQ2, by the way. But for FRQ2, you have to use this, which one of these two. You can't do Desmo to TI. You can't use regressions on FRQ2 to get your A and B value. Alright, so now try number 46. Yeah, try number 46. Okay, the answer for 46 is D. Is D. Explain. Okay. So it says we have a half-life of 3.8, which means it's to the power of 1/2 divided by x divided by 3.8. That's usually just how half-life works. That's like the half-life formula. If you have a half-life of some points. Then it says it has remaining after D days, and it can be modeled by the equation. So you don't have to even make it. They already gave you the equation. The test we're seeing is we're changing it to weeks, where A of 0 is the amount of times there are 7 days in a week, so D is equal to 7W. So from there, we see that it can't be A because that removes the 3.8. Then we look at the next one. 0.5 to the power of 1/7 3.8 times W. That doesn't work because that's still supposed to be divided by. How do we flip it to the other side? So now we're between these two. 1 to the power of 7 or to the power of 7. Well, it says D is equal to 7W, which means you're multiplying by 7 for every single D value. And it would also work if it was like 0.57W equals 2.8. Because D is equal to 7W, so that means you're plugging in 7W here. And that's our exponent property we learned earlier about power property, where M and N. Okay, any questions about this one? Because this is kind of important. Never learned this either. I think it's like 2.5 and 6, I think. I think it's 2.6 and 7, these topics. You don't get it? I'll try re-explaining it from the beginning. So, where do you get... Alright, so first, we have the equation it gave us, right? Is everyone good on that? First thing, we have an equation, right? Then, there's 7, it says D is equal to 7W. So, R of D is equal to A of 0, 0.5, and then replace that. Alright, that's not an answer for us. So we can also use the exponent property we learned earlier about M and N and go backwards pretty much. So then now it can be A of 0 is 0.5, and we can bring the 7 into the normal, into into the B value area and leave W divided by 3.8. And yeah, you're basically going from B to W. So yeah. Does that make sense? Does this explanation make sense? Just plug it in, pretty much. Yes? Okay. Alright, now try number 48 and 49. We will go problems over specifically the rules again. Like, which rules? Like the addition, like M. Yeah, okay, yeah, we can go over those. We'll go over those after these two questions. Alright, 40. If square root is basically power to the 1/2. Yep. Alright, 48 is D, and 49 is C. Any questions on these two? Or why is it D instead of A? So we'll go over 48. Okay. So first we have to make our equation. It says expected to increase, which means we start with it says, and it also had an initial investment. That's our A0. So 215 times 0 point increase. So that means we have to be positive. So 1.029. And it says expected to increase. So that means we're going to put our month value up here. And then it says if t is measured in years. And it says a month is 1/12 of a year. So we're saying a month is equal. We're saying, so you put year on the other side, is equal to 12 months, pretty much. So we put 12m is equal to year, and then we replace that. So now this becomes 12 months, and that would be D. Alright, you guys, any other questions between these two? Because I think we go into a new topic after this, so. Explain 48. Once more, okay. So first, you have the initial value, t is equal to 0 at 215. Boom, okay? Then, expected to increase by 2.9% a year. That means it can't be A or B, because that means it would be decreasing, because it's B is less than 1. B is less than 1 for both of these. So it can't be these. Now between these two, it says a month is 1/12 of a year, which means you have to go to 12 to the t. And yeah, you can rewrite it as in 12 to the m, or as the equation 12t. Exactly like here. Yeah, and you're going from months to year, not vice versa. If you're going from years to months, it would be this one. Alright. 49, the way you do it, it says it's decreasing. So it's finding an equation. It can't be A or B because we can see it's going by way more and it's like changing. So it can't be this. And it's dividing by 3. So for whoever asked that, I hope that made sense. Because you're dividing by 3 says 1/3. It can't be to the power of 3x. Any final questions on this topic before we move on to appropriate models and residuals? Nope. Okay. So now, appropriate models and residuals. So first, they'll go over the 3 types of models because that's important to do. I think maybe at the pace we're going, maybe another hour 30. But it's expect the time I put on the lecture is like 7:30, like as maximum time. So should be at the pace we're going. I think we're like halfway done right now. So yeah, let's see. Because now we go into like the little bit. We go back to like the harder stuff. Incorrect models, patterns. Yeah, okay. So first, the proper models and residuals. There's 3 types of models. You have a linear, a quadratic, and an exponential in AP Precalculus, and log, but we're not at log yet. Exponential have a relative constant rate of change. A quadratic have rates of change that are increasing or decreasing at a relatively constant rate, and they follow a U-shaped pattern. And exponential use an exponential when output values are proportional. Each successive output is approximately the result of repeated multiplication. Residuals. Residuals are used to predict values for a dependent variable given an independent variable. It's important to know that a residual, what do you call it? A line of best fit or a least square regression shows only predicted values. If the input value from a known data set is to find the predicted value using our model, the difference between the actual output and our predicted is called a residual. So actual output minus predicted. So y minus y hat, if you want to remember that. Y is what your data gives you, and this is what the line gives you. And then you can use a residual plot to check the appropriateness of a model. Residual plot shows all the residuals for a data set can be used to determine if a model is appropriate for a given data set. If a model for a given data set is appropriate, the residual plot should appear with no pattern. If you see a clear pattern, then the model for the regression was not appropriate. So actual minus predicted, yep. So now, any questions on the information before we go into the questions? Because the questions are just these 2 topics, residuals and the residual plots. Is the graph the actual data? It's the which graph? The residual plot? What's y hat? That's the predicted. That's the predicted output values. Y hat's predicted. Is there any way to access? I posted them in it's all the way at the top of the messages, or it's in like the lecture sheet. The values they give you. If it's like a table, which is the graph the actual if this type of graph is your residual, which means someone went and did y minus y hat for every single one and plotted them for you. And your TI-84 can also do that, but that's not part of this course. So we'll try number 15. We don't have to calculate ourselves. You may have to if it gives you like, I don't have a question like that, but if you, yeah, just analyzing residual plots, you may have to calculate residual, but that's just actual minus predicted. So if you have a line, a best fit, and you have a value here, you could you would have to subtract this value and this value. The Unit 1 lecture was yesterday. The Unit 1 lecture was yesterday at 7:15. So do 50 and 51. I'll give like another minute or 2 for these questions. Okay, like 30-ish seconds. Okay, I'll go over it now. So 50 is D, and 53 is C. Any questions? No? 53, please. So the idea is based on we're trying to see which is the most appropriate model. This has a clear pattern, so you can tell this is a clear pattern, and that's a problem. You don't want a clear problem in any type of stats, because that's what a regression model is usually for stats. So it can't be linear. Then this also has a pretty clear pattern. You can see that it's slow. It's negative residuals, which means that it's underestimating, and then it slowly starts overestimating, and then starts underestimating again, which means quadratic's also not good. And then here, it's pretty random. You can't really tell what it's. There's no clear pattern. You could think it's a sign, but it's not really a sign if you try like outlining it. So that means that's the best. D is just there for fun, yeah. They just needed one more answer. You could have another plot for log, but yeah. D is a distractor, yep. Now try these two. 54 and 56. Give like until I'll give 2 minutes for these. Yeah, the dots are the actual values, and the line is the predicted. And it's also your least squared regression, or your model, or your line of best fit. There's multiple words. Lots of words. If you ever take stats, you'll learn way more in depth for how regression lines are made, but it's pre-calc, so we won't go in depth into that. Give like 30 more seconds. Okay, I'll go over now. So 54 is A, and 56 is D. Any questions about both of these? Or anything you might go explain 54. Okay. So the predicted value at I'll go over both of them then. So the first one, the predicted, so it'd be y minus y hat. So our predicted is 2, and our actual is 1.5, and that's negative 0.5. That's this one. Yeah. If it's under the line of best fit, it's negative. And if over, yeah, it's that's how regret, because if your actual is bigger, if your actual is smaller than your line, then it's gonna be negative always. So it's that simple. So 56 says P and Q are labeled. That corresponds. They have opposite signs because one is above, one is below, so it can't be A or B. And there's a greater value in key Q because farther from the least, it's farther from the line, and that's it. Or you could calculate the residuals if you wanted to compare based off that. And a higher residual means a higher greater. A higher residual equals higher error. Yeah. Can I ask if I had to do find the value of residual, but how was the last one? I know it's a because negative, but I don't know how to find value. Yeah, it's y minus y hat. So for p, if for p, it would be the predicted's around like 2.5, I think. So the predicted is 2.5, and the actual is 3. So 0.5 for p, and for q it would be the actual is like 2.6. The predicted is 2.6, and the actual is like 0.5, which should be negative 1.1. So this is opposite signs, and this is bigger. So, and you would take the absolute value as it says the absolute value of the residuals. Yep, sure. Scroll back like here or like here. It's actual minus predicted. Yep, the previous question. Oh, okay. So, any questions on these two? Any final questions on these last two questions? Yeah, 1.5 minus 2. So yeah, it can be positive. Residuals can be positive or negative. Yep, that's why a residual plot has a line at 0 and then goes up and down. The actual is the dots, and the line is your predicted. If above the line, it's positive, and if it's below, it's negative. Yep. That's it. Okay, any questions on residuals, appropriate models? This is the last time we're going to see them for a good amount of time until tomorrow. Residual is actual, no, it's the other way around. Actual minus predicted. Y minus y hat. Actual predicted. So now moving on to 2.7, 2.8, composition of functions and inverse functions. So the way you sketch an inverse relation of a given function, we'll do equations again. Equations of exponent. That's calculator stuff. I'll be going over that we'll be going over that tomorrow in the calculator section. Because I don't want this lecture to be too long. Because it takes time to do Desmos and TI-84. So, composition of functions and inverse functions. The way you do an inverse relation is you flip the x and y values pretty much. So if you have 3, 4 in your original, your inverse would now be 4, 3. And that's pretty much this. 4, 3 becomes now 3, 4. 2, 1 becomes 1, 2. Negative 1, 2 becomes 2, negative 1. And negative 2, negative 1 becomes negative 1, negative 2. Yep, or and after you do it, it reflects over the y equals x axis. Yeah, you cannot say horizontal line test. So you would say something like how there's no repeated y values or something like that. So for this one, is the original relation a function? Is the inverse relation a function? The first one is yes, and the second one is yes, because it passes the vertical line test. And you could also say like there's no repeated x. After this, we're going to talk about. After this topic, we're going to talk about. Show you. We go to logs, then we go to equations, then inequalities, and semi-log plots. Equations, inequalities, and semi-log plots. Pretty much for the rest. And logs, because we haven't done logs yet. Okay. Because, let me see if I can find the vocab real quick. Yeah, you can't say, you have to explain how each input has one output or not. Yeah, that's pretty much it. You have to say if each output has one input and stuff like that. When you use the when you make an inverse relationship. Yeah, when you have an inverse relationship, you use vertical. When you have the original, you use horizontal. Moving on. Inverse relations and composition. I'll give like a minute or two for this, because this will definitely show up on your MCQ at least once. And FAQ 1 is all about inverses and tables and all that. So this is FAQ 1 pretty much. Good summary of FAQ 1. For example, 2b, doesn't the x value look like it's what? Repeating. It looks like it's repeating. No, it's just, I think I just drew it badly. It doesn't repeat. For to prove if it's an inverse, you would say for an input value for inverse, you would say for every input value, there is no repeat output value. For every output value, there's no repeat input values. Output value, there are no repeat, or yeah, there are no repeat input values. That's one way to say it. There may be a better way to say it, and I would personally ask in the AP Precalc channel when I could find a better answer to that. Problems 57. 57 is A, and 58 is C. Any questions on these two? No? Then we'll move on. Now do 63 and 66. Yeah, that really, yeah, that wording will work. That's one way to say it. Yeah, you could also cite specific points. It's not inverted. Yeah. Alright. Let's go over this. So 63 is C, and 66 is B. Any questions about these two? These are very important concepts, and they show up in both Unit 1 and Unit 2 a little bit. And a little bit in Unit 3. I think. Yeah, inverse shows up in Unit 3. For 63, you just do 2, you don't times it. So pretty much what you do is when it says f of x, you plug that in for this. So now it's going to be 2x minus 1 squared plus 3, 2x minus 1. Your x gets replaced in both of these. And then it says the function k, says for 66, a faster way of doing this, it says the function k is an inverse of h what is the minimum value of k? So yeah, you could look at the leftmost x value. So yeah, that's the fastest way of doing it. That is pretty much the fastest way, because if you flip it, then this would be your highest y value. Then this would be your lowest y value after you flip it. Alright. Moving on to these three. Actually, we'll do these three first. 68 through 70. Now we're doing inverse tables with composition of functions. So the answers are A, B, and D. Any questions? No? Wait to see if anyone else. Nope. Ah, nice. 75. The rational function is given by explain. Oh, it's explain. Okay. So first you find f of 2. So you're plugging in x for 2. That's 7. So g of -1 is going to be 7. And you find that at... Wait, hold up. Then you look at g and then you find 4. That's it. Now do 70. Find the inverse of this function. Of this rational function. This requires a good amount of solving, I would say. We have like only like 25 seconds. Okay, and 75 is C. Any questions on how you would do this? How did you get C? You got D. So the way you would do this, if you do an inverse function, it would be x is equal to 2y minus 3y plus 4. And then we have to do x is equal to y plus 4 is equal to 2y minus 3. Xy plus 4x is equal to 2y minus 3. Then bring we're gonna bring x to this side and say xy minus 2y is equal to negative 4x minus 3. Factor out y. This would be x minus 2 is equal to negative 4x minus 3 divided by x minus 2. X minus 2. Y is equal to c. I'm not writing that down. 4x minus 3, x minus 2. Did that make sense? How you find inverse for any function is just flipping y and x. I see, fake taker. That may work until they give you a different function except a rational. What happens if they give you a polynomial? What are you gonna do when they give you a polynomial? It's not gonna work with polynomials. Yeah, I used to check these. Yeah, okay. Now we move on to logarithms. So first solve these first like four. We'll do all 4 questions. I'll give I guess 5 minutes. I'll be back in 5 minutes. I gotta go get some water. Okay, 3 more minutes. Okay, actually no, 2 more minutes. So I my people have answered. The answers for 77 through 80 are C, A, D, D. So C, A, D, and a D. Any questions on any of these? 78. 78. So the way you do 78 is it's log 3 of 1/9. So you can convert that into an exponential by saying 3 to the what power equals 1/9. So what power do you have to take 3 to get 1/9? And a negative power is you take the reciprocal. So 3 to the negative 2 is equal to 1/9. And you flip it. Yeah. Any other questions on these? 80. So 80, the way you do this is you would say log 10 of x is equal to 1, and then you would do the same thing I did up here by switching from log to exponential. It would be 10 to the 1 is equal to x, because it's your log base to the power of your answer to the equaling your argument. So that's why x is equal to 10. Does that make sense? Ran 1z y. Yeah. So now try these. Try both of these. Alright, I was just trying to see if I could scroll to fit something, but it's not. My bad. I'm not talking right now, that's why you couldn't hear me. That's fine. Can you explain 82? Yeah, I'll explain after I go over the answers for both of them. The answers for 82 and 83 are B and C. So for 82, the way you do this is it's an exponential function and it says you're flipping it to a log. Which means, as we talked about before, where an inverse is just xy becomes yx, you flip them first. So it can't be this, can't be this, and it can't be this. And that's just it. You have to flip the y into x. Why is it B, not D? Yeah, pretty much that's it for this. Just flip x and y. Yeah, that's the easiest for an inverse. Just flip x and y. And because we flipped it, and when we flip it, we keep in mind the horizontal and vertical asymptotes. We don't have to restrict it like this. And this is the range of k is not restricted. It's x. Yeah, it's x for this, not y. Does 83 make sense to everyone? This year's this is my first year taking it as well, so that would be a question for the cool savage perchance. It should be similar. They don't usually change the difficulty just because it goes online or it's a second year. So the way you do this is you're just dividing by 2, and that's proportional. And this is going by up to, so that's log, because the input values change proportionally as the increase in equal value length. Any questions on these two before we move on? Oh, next, we'll do these two. We'll do 85 and 86. So for these, for 85, it is, yeah, they're both B. B and a B. Any questions on these two or no? '86. So the way you do 86 is the normal, so the normal log graph looks like this. So you have an asymptote here, and it looks like this. Which means and it's just a ratio, which means you're just maybe multiplying it up and down. You're not making it negative, which means it's increasing and the graph is concave down. And now we'll go over 87, 88. So I'll go over it now. So the answers for this are C and C. And the way you do this is you use our normal log graph and now you flip it. So now it's decreasing and it's concaved up. And for this one, same idea. But now there's just a vertical shift upwards. You don't have polars yet? What is there's a polar like lecture. Yeah, we had a polar lecture recent, like 2 weeks ago. It's on the 5 Hive spreadsheet. For the people who haven't learned polar yet. Yeah, I don't know, but I'm just gonna ignore them. So, moving on. 89 and 90. Now we're on limit notation with the same end behavior stuff. Yeah, polar, the best way to do it is just plug and graph. So 89, 90. And if you're still here, try to participate, because that's the best way to do math, by practice. On the exam, max 2 to 3. That includes the coordinates and the graphs, like all 3 of them combined. Max 2 to 3. On 0 on FRQ. I'm gonna give like 1 more minute for these two, because these are pretty easy. And we need to get to the harder topics, so. Okay, the answers are B and C. Okay, any questions on these two? '89. The way you do 89 is there's no flip, there's no vertical flips, so we still have our normal graph. So as it's going towards infinity, it's going towards infinity, as you can see. And if it's going towards, yeah, it'll be always the same. Except the negative infinity one, because it approaches the asymptote. So if for this example, it would be the limit as x approaches 0, k of x is going to be negative infinite. And no, the fraction doesn't flip it. It just makes it like more condensed. Let's say that. I'm confused with 89 and 90. So 89 is, so let me pull up in Desmos. For exponential functions, the asymptote is at 0. It's at 0. So for 89, I'm gonna keep the graph up here, but for 89, as you can see, it goes towards infinitely, and as on the 0 axis, it's going towards negative infinity, infinitely. So that's why this be as the limit approaches infinity, so positive x, it approaches infinity. For this one, you have a negative, which means instead of being like this, it's now flipped. So it goes like this with an asymptote infinitely. Which means log has vertical asymptote, exponential has a horizontal. Yep. And so as it approaches infinity on this one, now it's going towards negative infinity, because now this is going towards positive. Or you could just think of it as being flipped. Instead of going towards positive infinity is normal, now it's pointing downwards. So do those make sense to anyone who had questions on these two? Because these are our last limit questions. Now we're on equations and semi-logs for the rest of the time. Now, properties of logs. Addition is multiplication. That's the product property. Division is subtraction. And exponents inside the argument go on the outside. Do these three properties make sense to you? Because these properties are very important for FAQ4. So it's like everyone's answering. So 94. We're going to 94. Okay. And 94 is C. Any questions on this? I said 94 is C. Maybe it's kind of I'm reading the chat, so maybe that's why. All right, 94 is letter C. Any questions on this? All right. So the reason it works like this, right, is ln would become 4 plus ln of x to the third, and then you bring the 3 out, so it'd be 3 ln of x plus ln of 4. And the reason why it wouldn't be b is because the third to the power of 3 is only to the x, not to the fourth. This exponent is only on the x, not the 4. If it was 4 to the third, then yeah. Does that make sense to everyone? Alright. So now, will they do different base stuff? Let's change a base, and we will go over a little bit of that for like a question, but that's really it. I forgot how to change base, and then we'll review it. Alright, so try 90, let's try all four. I'll give like another 3 minutes for all four because there's a little bit of algebra. Remember to answer all four questions. 96 to 102. Okay, I'll go 1 more minute. You don't get 100? Okay, I'll go over. Alright, so I'll go over. So 96 is C. 100 is D. 101 is B. And 102 is C. 100 is change of base, which is log of A over B is equal to the log of B over the log of A, and you can put whatever number you want here. And so you would put, and you can use ln as well. So that's why it's not, and it would be 9 and 4. Alright, which one's the next question? 102. 102 is the f of x equal log of 2 and log of 6x. So vertical translation. Yeah, it's because it's log A plus log B, so. Sure, I can do that. Let's see. If I say log of hello, what's the back row? To log 8 of 32. Use change of base and solve. Alright, I'll explain 102 while I wait for this. So the way you do 102 is you use like the property of addition, or the product property, where it says log of 2, 6 plus log of 2x, which would be a vertical translation. And the answer for this would be log of 2 would be 32 over log of 2, 8, which would be 5 over 3. And yeah, 1.666 if you convert it decimal. You can use whatever base you want. Yeah, it can be any base. That's what change of base is used for. It can be any base you want it to be. You can be, because remember, ln is just log of e. Yeah, that's why I put in 32. Now moving on to exponential equations and inequalities. This is going to be a little while. So first, our product property, power property, converting between exponential and log. If you need to alternate the switch the equation to the alternate form, if you need to solve stuff like that. These are important for FRQ4. This is like a summary of everything you've learned so far. So equations with multiple logs. When working with more than one log, we can use our log properties to simplify expressions. Form 2 is log a of x equals log a of b. To simplify the form 1, we can use exponential form, and then we can solve by setting up x and y. In either case, we need to check for extraneous solutions. Using logs can sometimes lead to solutions that are not in the domain. Log x plus log z does not imply x plus y equals z. Must be used log properties to simplify. We cannot just cancel out logs. So I will let you guys solve the first example and one of our examples. So solve. So now we are gonna go over the answer. So first, first thing to do would be, I would say, to make this into one log. So you would do log of 3 to the x plus 4, which is the call it. This would be the product property inverse, pretty much. So it would be log of 3x plus 12 is now equal to log of 5x minus 2. At this point, we're going to check for extraneous solutions. So what can x not be in this one? So our domain, pretty much. What can x not be for this first one? Yeah, it can't be negative 4. So x cannot equal negative 4. And what about for this one? Actually, it's not x can't be negative 4. It's x cannot be less than negative. And this is x cannot be less than negative 2 over 5. So now we can raise the base. So you can raise both to the power of 10. So it'll be 3x plus 12 is equal to 5x minus 2. Solve 14 is equal to 2x. X is equal to 7. Any questions on this one? You check for the domain by making sure the domain of log is not less than 0. The exponent multiplication rule is so trippy, but like x to the power of 2 to the 8 when done 2 to the third first, but rule says yeah, it should be. Yeah, it is different, but that's like an important property. Because if you don't do that, then these problems some of these problems will get really hard to solve. So any questions on this one before we move on to example 6? Nope. So now in the xy plane where all the x coordinates are the points of intersection of the graphs h and k. I'll give like another minute and a half this question. The answer for this one is x is equal to 3.5. Any questions on this one? No? Just wait. See if anybody does have a question. How you do it, Ed? So first write the thing. And plus log. All of these questions are Brian Passwater. The multiple choice I posted in the Precalc channel, and these are from his notes. All these free response questions. He is a very famous person who made a lot of AP Precalc resources. So the first step would be to first do domain restrictions. So that means this x cannot be less than 3/2, x cannot be less than -4, and x cannot be less than x cannot be less than -1/4. So pretty much this is the x over. This is the one that really matters because that's our positive values. Can you just plug in both values and see? Yeah, that's one way to do it. So then, now the reason I'm doing it like this is it's important for inequalities. It's the same idea for inequalities, which are a little bit more difficult. So then simplify this into 1. So this would be 2 of x minus 3, x plus 4, log of 3 of this, and then equals log of 3, 8x plus 2. And then raise both to the power of 3, so then we can cancel out our logs, which means 2 of x minus 3, x plus 4 is equal to 8x plus 2. From there, multiply this out by factoring. Brian Passwater is a person who made a lot of resources. What if the change? Then you would have to use change of base to solve. And then you would factor this. You'd eventually factor this, which would be 2x minus 7, and some other value, which I do not have right now, and this would be 3.5. Oh, thanks. X plus 2. And this would be negative 2, and that's outside domain restriction, so we cancel that out, and that means x is equal to 3.5 is our only solution. Any questions? Would assume so the name is Brian. Yeah. So yeah, he's just a guy that makes a ton of great resources. Lots of FRQ practice, MCQ practice. Now we looked at inverse. Now find inverse. So now find the inverse of this function. Switch x and y, use inverse operations. Write the final inverse operation using correct notation. Can you please make it bigger? Let me see. It's better. I'll go over the answer in like a minute. So I'll go through. So it would be x is equal. Could you explain which one is most simplified? Alright, so x is equal to 3 to x plus 4 minus 15. Minus 15. Add 50x to both sides is equal to 3 to the 2, x plus 4. Now divide by 3. X plus 15 divided by 3 is equal to 2 to the x plus 4. Now I would say use the
the log this form. So this is the logarithmic general formula. So we're gonna use the transitioning, just converting from log to exponential. So log of 2, where you put this inside the thing, is going to be equal to x plus 4. This started at 4 p.m. or 2 hours ago. The recording will be posted, though. It may just take a little bit longer because there's like 2 recordings because it got split. It kind of split in half. So then this, and then you would say x is equal to, oh yeah, it would be y of 4, yeah. But, so yeah, y of 4, y of 4, y of 4. Yeah, y of 4 log would be x plus 15 divided by 3 is equal to negative 4. No, minus 4. By pulling the 3 out, you could say y is equal to log 1/3 x plus 5 minus 4. And that would fit that would fit this form perfectly. But this would be, I would say this would be accepted most likely. Because it's in the general formula form. Well, you could do that. We didn't go over regressions specifically, but we went over arithmetic and geometric sequences. We went over exponential logarithmic prop. I've been doing this lecture for 2 hours 20 minutes now. It asked for yeah, in effort if they ask in FRQ4, they would want in this form. Just 1 log. No, we're gonna go over all the calculator stuff tomorrow. Because I have a full calculator effort, like Q&A, so we'll go over some general stuff if anybody asks. Alright, so now try solving this one. Tomorrow's calculator plus Q&A. You do some simplified, where the FAQ said to simplify. Can you do some simplifying exponentials later where you said to simplify the equation into 4 to the a. Alright, give us 3 minutes. Okay, yeah, I can give you 3 minutes. I can go for as long as you guys want to go. I can go until like 8 o'clock. So we still have an hour 40. So, and there's like another like 7, 8 questions left. So you can go for as long as you want. It just may take the recording longer to upload. Yeah, it may just take the recording longer to upload because it gets longer, but that's really the only issue. Yeah, you're central. Yeah, okay. That makes sense. So we plug in -1 for each of x. I'll go over it. Let me just find the answer real quick. All you have to do is solve and then swap and solve for x and solve for x. That's all you have to do every time. Solve for y. Okay. So I'll go. Are you guys ready for me to go over it? Alright, 1 minute left. It's fine. We only have like 6 questions left, so we have 3 more solving and 3 semi-log plots, and we're done. So
If you want to go through more MCQ practice, what should I do a day before the exam? What should I do a day before the? Okay, so how much have you done so far? That's always the question, because cramming stuff is never worth it. It's been proven by science. It's been proven by like multiple teachers. How cooked them? You're not that cooked. How much do you know? I will give I will do a confidence boost session on Sunday or Monday, depending if I do another one on Monday. So, if you how much do you know? Because I need a visit unit 1 MCQ, particularly unit 3. That is good enough. Okay, your answer. Okay, then we will go over it. A lot of people said 7, so I'm gonna assume that's right, and I will go over it once for the recording. So, first of all, it says like so you have to find the inverse first. So we're gonna find the inverse. So x is equal to 3x, 3y plus 1 minus 2, x plus 2 is equal to 3x plus 1. Then do the log converting property and greens. Things are in AP Precalc pins. There's a ton of FRQ, MCQ and FRQ practice from Brian Passwater. From there, you do log of 3x plus 2 is going to be equal to x plus y plus 1, and then subtract 1, so y is going to be equal to log 3 of x plus 2 minus 1. Can we do like this one for unit 3? I went over a ton of these. Like a unit 3 lecture, we already have multiple. Yeah, I think that's where these questions are from. Cosmic, from Brian Password, these packets. Most of these MCQs are from his packet. Cause it's x plus 1. Where did y get x plus 2? Cause we flipped. If this is y, we flipped it. You just click pins. You just click the pinned button in the top right corner. I didn't show it after, like near the end of the lecture if you stay. I don't know of a resource like that. And then it says where is equal 1, so 1 is equal to log 3 of x plus 2 minus 1. 2 is equal to log 3 of x plus 2. X plus 2 log of both on both sides. 9 is equal to x plus 2. X is equal to 7. A semi-log. We'll go over a semi-log in depth. That's the only section that's very detailed. IXH I the MCQs are pinned in the mathematic justification guide. Okay. Now this is when we're supposed to go over change of base, where it's just log of b becomes this and this. Why did I set equal to x? Because I switched the x and the y. So if this was y is equal to 3, x plus 1 minus 2. I flipped it, and I said x is equal to 3, y plus 1 minus 2. That's an inverse function. Does that make sense, Greens? A mathematic justification guide is pretty much your interpretation guide. It's pretty much just an interpretation guide in simple terms. They have interpretation guides for other subjects. I didn't know they had it for AP Precalc. Yeah, my teacher would. Interpretation guide is pretty much like what do you have to write to get like the full points, like on like a free response question usually. Like AP Stats has multiple interpretation guides by Stats Medic. I don't know about AP Precalc. I haven't looked at. AP Philosophy would be torture. But okay. Now using the change of base formula, solve. This is what someone was asking before, how would change a base work? This is your change a base. Solve for x, yeah. That's what you always have to solve for. You scroll enough to see the formula, yeah, sure. You should definitely memorize this formula. It could show up on FRQ4, maybe, or an MCQ. You know how people find it easy? They practice a ton. That is how people find it easy. It's not that much to memorize. It's just you keep practicing, eventually it becomes muscle memory. That is what math is about. Practice. The only memorization you have to do is maybe like the trig identity formulas like double angle and sum and difference. But with enough practice, that practice will be. Yeah, I also do like math over history, so it kind of does help to stay focused. We haven't done yet. Oh yeah. Maybe in class. All I gotta do is think of a hypothetical formula that might exist, check values to see if it exists, formula exists. Yeah, that's one way to do it. So for this question, I will just post the answer because it's a lot of work. I have the answer on a different sheet of paper, so I will post the answer, and then we will go over it if anyone has any questions on it. So this is the answer. Any questions about it on any of these steps? Yeah, okay. Hold up. Yeah, hold up. I'm trying to zoom out a little bit. Right there. I can keep the entire answer. While you divide by x to the power of 1/2, how did it turn to 1/2? This turned to 1/2 because you did change your base of this log of 4x, which is, if you change your base that would be log of 2 of x and log of 2 of 4, and log of 2 of 4 is 2, and that's in the denominator, so that becomes 1/2. And then it uses x 1/2, and then it solves all that, and then you bring that in, and yeah. And if you couldn't tell, this is a teacher's handwriting. We did this in class, so yeah. Questions like this could show up, but it's unlikely because this is a lot harder than the other type of questions they've done before. But it is only 1 year, so this is the second year of the exam, so. You missed what? What did you miss? I left for a sec. Oh, okay. I just posted the answer for this question, the change of base formula question. That's it. You have 5 minutes to do this in theory. They could make the other parts easier, but change of base is this. Hold up. Change of base is this formula. Are you guys sure Alright, the structure will stay the same. And I don't know why the structure and the functions might change of FRQ2. Because FRQ2 is a non-periodic context question. I don't know why you pinged the cool savage. I don't even think he's here anymore, but could FRQ2 be a polar function? Oh wait, FRQ2's the instructions say a non-periodic function. A non-periodic function in context. So any function that's non-periodic can show up on FRQ2. So theoretically polar, I wouldn't consider polar periodic, but some people would. So periodic means like the period, having a period of like 2 pi and stuff like that. 2 point, yeah, sine, cosine, tangent. That's talking about g of x. No, we're talking about FRQ2 currently. The only time there's an FRQ lecture that the cool savage hosted, so you could. What it is wait, for 2, yeah, g of x, what is it mostly? Alright, FRQ2 is a non-periodic function. We'll go over that at the end. I think we'll finish before 7. I'll spend 30 minutes reviewing Q&A, I guess. We'll first finish, then we can actually like do that. So, so let me continue. So the next question, alright, so this is an example of how to solve an inequality. So, first of all, you find that it's the same thing as before. Yeah, this is the hard one, I would say, for sure. So for this, first simplify, rewrite as an inequality because log 10 to the power of 0, 10 to the power of both sides is 1. Solve, and then you have to keep in mind can't be 0. Yeah, that isn't that hard. This isn't that hard. Yeah. So I hope any questions on this example, because this it's less than, my bad. It's not less than to equal. It's less than. I made a mistake up here. It's less than. It cannot equal it. What is the cyan part? So like if you try to find the zeros right of this, that means the discriminant is negative, which means there's no possible. It's an imaginary solution. So that means they have no x-intercepts to find this thing up. Does that make sense? Okay. Does this example make sense? Because the next one I'm just going to let you do it and I'm going to show the answer. The green part has the own, yeah, it's pretty much the, what do you call it? The domain restriction. Yeah, the domain restriction. I hope this example makes sense. Good luck with this question. And I think this is our only inequalities question because it takes a long time to do. This is the only inequalities question that's FRQ, so that I have in this slideshow. So I will give 5 minutes for this question. And while we wait, please fill out the lecture feedback form before you leave so that next time or next year when I do lectures, I improve. Because took your advice from last time from some people who said it was a little bit unorganized, which I do agree on, so it's a little bit more organized this time. So appreciate it if you fill the lecture feedback form. But we still have another full topic to go, so you cancel in from both sides. You can, but you have to keep in mind the natural log. Yeah. You just have to keep in mind the domain restrictions. That's the one rule. Okay, you don't have to type the entire answer out, just say when you're done. Cause I think it's gonna take a long time to type the answer if I remember correctly. I don't know the exact answer, so I just have the answer posted below. So I'll go over it, but this one didn't take long. Oh, okay. I thought it would take longer. It looked long in the answer. So I guess I will give another 30 seconds to you're supposed to get imaginary, I think. I don't know. We'll go over it. 3, 2, 1. So first, you find the domain restrictions. You realize that you can't factor it, so you have to use the quadratic formula. Using the quadratic formula, you get two numbers. It has to be greater than 1.792 and less than negative 2.729. Isn't it just one zero that quadratic to the other zero? I would assume it's calcactive because she did square root of 21, but it could be different numbers. Okay, but still. Then this is x negative form. Then we solve. Rewrite, and then you do less than 1, solve, factor, all that. And then you test values. When you test in between. So now you see that we have 4 has to be greater than 4 because of the first domain restriction. This one says it has to be less than, and this one says it has to be greater. So that means it can't be anywhere in between. And then we start testing values. Plug in maybe like negative 2.8, 1.8, and then you have to check the values of the calculator. Yeah, I think this would be a mix of a calc and non-calc question, or they would just use simpler numbers. Yeah, I am speaking. Wait, can you hear me? Can anyone else hear me except the fake kicker? Okay. So now, multiple choice version of this. This is more AP Precalc style question. This is an exponential though. I will post the question in the chat, and I'm gonna open something. So then, if we do have time, we can just go through practice questions if anyone wants to for any unit. Yeah, what's your question? Okay, like practice, like later. Okay. Freddie, yep, I'm locked in. It's just the beginning was a little bit rough. I'll say that for anyone that was here since 4:30. Most teachers are supposed to over prepare me, like my teacher who way over prepared us for this exam. Some teachers, yeah, it's almost been 3 hours. Yeah, I do agree. But I can go strong for another like hour and a half, so we'll go until people can't take this thing any longer. May host one. We have one more tomorrow, Q&A, and then we'll have one more. Maybe Monday. Potentially. Sunday's guaranteed. Yeah, that's the next topic. After this question, it's semi-logs. This is the last, this is 2.13, and then 2.14 and 15 is. One more thing, semi-log plots is the last thing we have to cover after this. And then I'm just gonna leave it to open floor plus. Okay, you need to do. You don't have to know any of those. You don't have to know half angle log. You don't have to know any of those. Those are not part of AP Precalc. You do not need to know half angle. You do not need to know law of sines, and you do not need to know law of cosines. That is extra. Okay, the formulas you need to know. Okay, I'll start with trig because that's the easy one. I will actually go over one. I will go over a reference sheet that someone nicely posted in AP Precalc, and I got the permission to cover it. So, no unit 4, right? So for 125, the answer is B. Any questions on this? Yeah, that's all the trig identity. Okay, how do you get B? So first it says h of x is the composition of f of g of x. So that means we're plugging this into here. So log of 3 of 9 of x minus 1. And then we're going to simplify that because that's always easier to simplify. So 9 of x times 1 over 9. We're going to simplify that into two separate ones. Log of 3, 9x plus log of 3, 1/9. This is going to be negative 2. This will be x log 3 of 9. Log 3 of 9 will be 2x minus 2. Yeah, okay. 2x minus 2 is greater than 3. 2x is greater than 5. X has to be greater than 5 over 2. And that's B. I hope that made sense to anyone who did not do like equals when converting from logs to exponentials. I didn't convert from a log to exponential. This is me plugging in g of x. This is me plugging f of x into g of x. This is me plugging it into here. Why is it 2x and not 2 to the power of x? Where? The last step. Not because log 3 of 9 is 2, and it's not in the exponent, so this would be like that multiplication rule, like I'll show you. It's this multiplication rule that x of n is n of x. So we use that formula instead. Does that make sense to everyone? Wait, hold up, I went too far. Does this question make sense? Because this is the only exponential inequality one that made sense. After calculating, you'll just multiply instead of raising it to the x. It makes sense? Okay. Finally, we will cover regressions in the calculator tomorrow. So our last topic is semi-log plots. Semi-log plots, one of the scale axes is logarithmically scaled. In AP Precalc, we'll be only scaling the vertical axis. With semi-log plot, you'll see where the exponential functions will appear linear. This is important. So this is the human growth and over time and in the United States, and that's exponential growth. And now on the right, it's been logarithmically scale, so now it looks pretty linear. Keyword pretty linear. When we logarithmically scale, we're not changing the actual y values of the data. To logarithmically scale, the y-axis must be equally spaced on the. Okay. And the linear models, the formula is log b of n, log base n of b x plus log base of na. This is the formula that you guys were talking about for linear. Yeah, that's it's a linear equation formula. It's just now our slope is this and our b value is this. How do we get m and b? That's just m is equal to log of m, and b is equal to log n of a. How many questions? Maybe 2. Yeah, I do. So node number 1, the slope of our linear line is this, and our y-intercept is this, and the base n corresponds to the base used for the scaling, which is going to be 10 in most of our cases because we're scaling by 10. So now an example question. First, MCQ. 134. Which of the following could be f of x? Okay, the answer is A. It's A because it says the original function is an exponential decay because our slope is decreasing, so that means our thing. And it says what's the function of f of x, not the semi-log plot. So yeah, because it's decreasing. Yep. And it can't be this because that means it would be increasing. This would be looks weird on a semi-log plot. And I will be going over how to graph semi-log plots in in Desmos tomorrow. A logarithm is pronounced a logarithm looking graph. Yeah, sure. Try 139. Yeah, I don't think I want to say this in the recording, so. I forgot a spoiler, but it's fine. It's fine. The answer for 139 is A. Wouldn't these be exclusively concave up because exponential growth by reflection is concave up? That is true. But remember, you can also have negative 2 of x. Yeah, don't circle your answer. On the FRQs, do not circle your answer because they will only grade what you circle. On the MCQs, do not circle your answer. Yeah. On the MCQs, you choose online data, but on FRQs, like if you get a final solution of like 2 is equal to x, right? Do not circle it because if you circle it, they will only look at this. They will not look at any other work. Or if you like wrote the right answer somewhere else, like up here maybe by accident, and like you made a mistake later on, they will give you the point for this. You circle it, they will not look at this anymore. So never circle your answer on the FRQs. My teacher told me, and she graded like she said she graded like 6,000 FRQ2s, so. And like all 3 versions, like the international version and all those other versions. I don't know if the work is invalidated, but if you write the right answer somewhere else, then they won't give you the point for it. So if you like for this example, if you wrote both of these answers, Okay. You circle my work. Okay. It depends on the teacher and who the grader is. If the grader is really nice. Circling is bringing there. Okay. Depends on the grader. Yeah, I usually box my answer, and then I boxed it and she said not to. So. Did everyone understand 139? Final question. 142. Is this model appropriate? And is what type of model is it? Yep, the answer is D. Okay, so that is the AP Precalc Unit 2 lecture. Now I will open the floor to questions, but before anyone leaves, please fill out the feedback form if you're gonna leave. But if not, then I will open the floor to questions, and I'll do a quick review of Unit 2 in summary. So thanks to whoever, someone posted this, but Alexander Lego posted it. And this is a summary of Unit 2. You have geometric sequences. I do not have these packets. Someone posted this, but you have the exponent rules. You have AP Precalc pins. By the way, this is an AP Precalc pins. I'll just go over some important stuff. Geometric is G of R and this, when is it increasing? They increase by larger amounts. They have ratios. Arithmetic is linear pretty much. This negative exponents are radical exponents. Types of exponential graphs, if a is greater than 0. Vertical dilations, horizontal dilations. Half-life, these, I didn't go over these, but half-life is an initial amount that shrinks by half amount every day. Percent increase is added decimal. Percent decrease is subtracted decimal, and doubling time is how much it takes to double every day, or D. Language used for exponential relationships. Exponential relationships model growth patterns with successive output values over equal length input intervals that are proportional. This sheet is in the AP Precalc pins. It's like the most recent pin, and I got permission. So K values distort the proportionality of exponential functions. This is what how many people were in the peak? I think 25-ish in the beginning, and then it dropped significantly. Even though 80 people signed up, so I think it's because the ping didn't go out. The AP Precalc people who signed up, the ping didn't go out, so I had to ask a mod to ping for me. So it was weird. So it's fun. Next time I'll start exactly at 4. I think because I started early, it broke it, but. So K value is distorted. This is the thing they were talking about before. If there's a K value, it distorts it. So that ruins the +2 thing. So you have to find the K value. Residuals are actual minus predicted. A good residual shows no distinct pattern, and a bad one shows a distinct pattern. Inverses are invertible, and notation is f of -1 of x. Domain of composite functions are when your domain and range are flipped. And the domain of your composite function is and the domain of your composite function is both of your functions, is your final function, pretty much. Like in this example. 2.5 is 2.15 is logs. It shows all the log formulas. It says expanding, condensing. It shows sign charts, initial restrictions, log scales, semi-log plots, and if you want to do logarithmic regressions, you use the calc section. Any questions on Unit 2? And then I will go. You're good? You good on Unit 2? Then I will open the floor to Unit FAQ structure. Sure. Okay. First let me answer what trig functions. First I'll answer what trig functions you need to know, because that was the first question. So
The 6 trig functions we have to know are sine, cosine, and tangent, secant, secant, and cotangent. And and if you're gonna leave, by the way, please post about the lecture form, and I will end the recording right now.